Hello, welcome back. I'm sure you missed me and my wonderful notes videos, or some of you did. Well, my joke today is, what did the one math book say to the other? Don't bother me. I have my own problems. Well, hopefully we can dive into some problems today. Your table of contents, take a look. It might have been a while since you filled it in. Make sure you have lesson 3.2. Which was the linear expressions. And the lesson 3.3, which was solving equations with addition or subtraction. And then now we are on to lesson 3.4, which is solving equations with multiplication or division. So make sure that's up to date, and then let's turn to that page, or you can pull out your handout that I attached on there as well. So up at the top here, these are some general ideas or key ideas we need to cover. And these are what we call properties of equality. And they're like rules or the theories behind why we can solve equations the way we can. That first one is called the addition property of equality. And this is just saying if A and B are equal, so if you have an equation where something equals something else, then A plus C is going to be equal to B plus C. So it's saying that if you add the same value to both sides of your equation, it's still going to stay equal. That's why in lesson 3.3, we were able to add something to both sides to solve for the variable. And so this applies to all four of our operations. So that also works for the subtraction. I'm going to make this a little shorter, property of equality. That again, you could subtract the same value from both sides of the equation and it would stay equal. And then this also will apply to what we're doing today when we look at the multiplication property of equality and the division property of equality. So again, saying that if you have an equation that's equal, you could multiply both sides by C and it will stay equal. Or you could divide both sides by C and it would stay equal. For the division part, C just can't be equal to 0 because we can't divide by 0. That doesn't work in our number system. So these are the technical terms for what we're doing and why we're able to do them. I just want to make sure you have them there. You won't use them too much, other than in geometry in a couple of years, they do come back up. So I want to make sure you've seen them and you have them in your notes. So let's dive into those inverse operations. So just like our last lesson, inverse operations are operations that undo each other. Multiplication and division are inverse operations. Those are the two we're focusing on today. For example, to undo multiply a number, you would have to, well, it's the opposite of multiplying, divide that number. So when you see multiplication, you will either see a dot like this, 2 multiplied by x, or they'll be right next to each other, 2x. Those are both multiplication. For division, it may look like a division symbol, and then a lot of times it'll look like a fraction, like x divided by 3. So those are the two ways you'll see it. Let's look at the division first. So we're going down here to the example 1, equations with division. Here are the 4 steps I recommend you follow to stay organized in your work. Because like I said, you need to make sure you're showing your work now when it's easy, so that way when it gets harder, you don't have to learn how to show your work at the same time. So first thing I recommend is to circle the variable. This shows us what we need to isolate and our goal to get alone. And then after that, we need to identify the operation. Because once we identify the operation, then we can apply the inverse operation to both sides to isolate the variable or get it alone. And then we always want to check our answer. So let's see this in action. Here's our equation. I'm going to write it over here just so I have a little bit more room. First, I'm going to circle the variable. That tells me this is what I need to have alone. So everything else on this side of the equation, I need to get rid of. This divide by 3. Oh, I just did the second step, identify the operation. This is division. So that tells me inverse of division would be multiplication. So I'm going to need to multiply to get rid of this. So I'm going to multiply by 3 on both sides. Whatever you do to one side, you have to do to the other. Then multiplying by 3 and dividing by 3 are opposites, so those cancel out. Because think about if you had divide by 3 and then you multiply 3, it undoes it, just like we were talking about here, undo each other. So all that's left over here is x, and then -6 multiplied by 3 will be -18. Now let's make sure to check this. And to do that, we're going to plug -18 back in for x in the original equation. So -18 divided by 3 equals -6. Well, -18 divided by 3, that is -6. So yep, we got it right. I always like to put a box around my final answer. That's my way of saying, yep, I checked it and I'm confident this is correct. Okay, let's look at another one. So I'm going to write this again over to the right so I have a little bit more room. Notice it is a negative x divided by 4. Now remember, when we have a negative fraction, you need to put that negative to the top or the bottom. We're going to move it to the bottom, so that way it's with that 4 and we can get rid of it together. So circle my variable. My operation is dividing by -4, so that tells me the inverse operation would be multiplying by -4. So these cancel out. I'm just left with x. And on the left, -4 multiplied by -10 would be +40. Let's go ahead and check that. So -10 equals negative rather than x. I'm going to write in my answer 40 divided by 4. Well, 40 divided by 4 is 10. Bring down that negative. Yep, -10 equals -10. Great. So right now, I want you to go ahead and pause the video and answer these two questions on your own. Okay, if you had any trouble with those questions, here's the work for those. Feel free to pause it and copy down the work or take another look. And here was B. Okay, moving on to the back side. Equations of multiplication. So we're going to follow the exact same steps. There is one type of problem that you may come across that looks scary, but really it's not too bad. So I want to make sure we cover that. So we circle the variable, we identify the operation, and we apply the inverse or opposite operation to both sides to isolate the variable, get it alone. And then you check your answer. So here, I'm going to write this problem out, circle my variable. That means, okay, I need to get rid of everything else on this side. I want n to be alone. So this is 1.5 multiplied by n. That's my operation. So the inverse would be to divide by 1.5. So I'm going to do that on both sides. This cancels out. I'm left with n equals, well, 3 divided by 1.5. That's going to be 2. And then I just need to check it. 1.5 rather than n, I'm going to plug in what I found, 2. And 1.5 multiplied by 2 would be 3. So yep, I got it correct. Okay, let's take a look at this one. So I'm going to rewrite it. Circle my variable. And I notice that I need to get rid of this -4/5. This is -4/5. There we go, a little blurry. -4/5 multiplied by x, so it's multiplying, meaning I need to divide then by -4/5. And I need to do that on both sides. Okay, so it is multiplying by -4/5 and dividing by -4/5 undo each other. So those cancel out, I'm left with just an x. Now I have this -8 divided by -4/5. Now we have to remember how to divide by fractions. So make sure you put all whole numbers over 1, and then we do keep change, flip. Remember my awesome rap for those of you that watched that video? Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. I assure you I'm dancing hardcore as I say that. Wish you could see it. Okay, then we can keep the first one, multiply, or change the sign, and then flip the last one. And then we can go ahead and multiply straight across like normal. Remember, if you have a negative fraction, to put that negative to either the top or the bottom, not to both. So I'm just going to move it to the top there. And then we can multiply. Negative 8 multiplied by negative 5 is going to give us negative 40. And then 1 multiplied by 4 is going to give us 4. And then negative 40 divided by 4 will give us negative 10. Let's go ahead and check that. So I'm going to do negative 4/5 rather than x. I'm going to put in negative 10 equals negative 8. Well, let's multiply these fractions. So it's going to be negative 4/5 multiplied by negative 10. Put that over 1 since it's a whole number. Negative 4 multiplied by negative 10 is going to give me negative 40. 5 multiplied by 1 would be 5. Negative 40 divided by 5 is going to be negative 8. So yep, the answer is, x equals negative 10. Okay, at this time, I want you to go ahead and pause the video, answer these two problems on your own. Okay, if you need some feedback on how you did on that first one, here's how to do it. You need to divide by negative 4 on both sides. And then for B, this one was that fraction one. You would have to divide by 2/3 on both sides. Here's the work, and then to check it. And last one, go ahead and solve this last one on your own. It's a little tricky. I do want to give you a hint. This is a negative a equals negative 24. When you ever see a negative alone, there's this imaginary 1 there, because multiplying by 1 doesn't change the number. It's the same. So as you get older, mathematicians like to leave that 1 off for it to be more simplified. But if you think about that negative being a negative 1, it makes it a little easier to figure out what you're doing. Keep in mind, this is multiplication, not subtraction. You're multiplying by a negative 1. Some students see this negative 1 and think, oh, I'm subtracting 1. I need to add 1. Nope, look at what's happening between the number and the variable. Okay, so for that one, it should look something like this. You got a equals 24 and then checking it. Awesome. Nice job, folks. Go ahead and try the practice assignment. Remember, you have unlimited attempts. Keep doing that practice assignment until you know how to do all those problems, and then go on to the exit ticket. Have a great day. Bye.